Welcome student in our YouTube channel Physics by T C Chauhan Sir. Today we are going to discuss another application of Gauss Theorem in which we are going to find electric field intensity due to a solid metal sphere. Solid metal, remember, solid metal sphere or solid conducting sphere. There is a solid conducting sphere. It is a solid. It can be iron, copper, aluminium, etc. Solid metal sphere is there. Its radius is supposed to be capital R. When it is given particular charge, certain charge, then charge will get distributed only on the surface. The question arises why it will distribute only on the surface. Because of potential barrier developed by the ions of the metal, charge will remain only on the surface. It will not get inside, it will not enter inside due to potential barriers of ions of the metal. Now, what about the direction of electric field intensity? It will be outward, normal and radial like this. It will be outward, normal and radial. Radial means along radius, outward due to positive charge. If there is negative charge, it will be inward. Now, how to find electric field intensity? For this purpose, surface charge density is taken. It is supposed to be sigma is equal to q upon 4 pi r square. Then q will be sigma into 4 pi r square. This is an important relation. This is useful whenever we are going to convert electric field intensity in terms of sigma, that is surface charge density. Now, the question is, first is outside. Outside the sphere, that is small r greater than capital R. The observation point is lying outside the sphere. This is supposed to be an sphere. We have to find electric field intensity outside it. Radius of sphere is capital R. We have to find electric field intensity at this point P at distance small r, which is greater than capital R. Then we have to draw a Gaussian surface, spherical Gaussian surface. On this surface, this is electric field vector and this is area vector. Both are in same direction. So angle between them will be 0 degree. Now, what about Gauss theorem? This is Gaussian surface on which area, particular small elementary area dA is taken, which is outward in direction, and electric field is also outward. It means both are in same direction. So whenever we are applying Gauss theorem, then theta will be 0 here. Now, what about Gauss theorem? According to Gauss theorem, integration E vector dot dA vector is equal to sigma q upon epsilon naught. Now, dot product will be taken out, then it will become E dA cos theta. Then it will be integration E dA cos theta is equal to sigma q. In place of sigma q, the charge present inside Gaussian surface is q. So it will be q upon epsilon naught. Now, theta will be 0 here because angle between E and dA is 0. So integration E dA cos 0 is equal to q upon epsilon naught. Then cos 0 is 1 here. So E integration dA is equal to q upon epsilon naught. Integration dA is elementary area. Whenever its integration is taken, whole surface area of a sphere is required. Whole surface area of a sphere, that you know, 4 pi small r square. That is sphere which is Gaussian surface. This sphere is virtual sphere taken in terms of Gaussian surface whose radius small r. So it will be E into 4 pi small r square is equal to q upon epsilon naught. Then it will be E is equal to 1 upon 4 pi epsilon naught q upon r square. This is electric field intensity outside. Now, if we have to convert it in terms of sigma, then you have to put the value of q. You know, q is equal to sigma into 4 pi capital R square. Let us put this value here. Then E outside will be sigma into 4 pi r square upon 4 pi epsilon naught small r square. This pi will get cancelled, 4 will get cancelled. You will have E outside is equal to sigma capital R square upon epsilon naught small r square. These are two results. One is 1 upon 4 pi epsilon q upon r square. Other is sigma capital R square upon epsilon naught small r square, that is outside. Now, what about on the surface, listen, on the surface, there will be small r is equal to capital R we have to put. This small r, the value of this small r we have to put in terms of capital R, then it will become E surface is equal to 1 upon 4 pi epsilon naught Q upon capital R square. We can calculate it in terms of sigma again. Let us put the value of Q, then E surface will be 1 upon 4 pi epsilon sigma into 4 pi capital R square upon R square. R square will get cancelled, 4 pi will get cancelled, sigma upon epsilon naught will be there. It means on the surface electric field intensity does depend only on the surface charge density. That is E surface is equal to sigma upon epsilon naught. Then inside. What about inside? Inside is small r less than capital R. Since inside there is no charge present, means inside sigma q is equal to 0, then flux phi is equal to 0, then electric field intensity inside will be 0. Remember, there is no charge inside, so there is no flux. Whenever there is no flux, there will be no electric field intensity. Then at center this small r becomes 0. At center again electric field intensity at center will be 0 because it is inside, and inside there is no presence of charge, no presence of flux. Center is since lying inside, so it will be 0. That will be the electric field intensity. Now what about the graphical representation? Graph between E and R. What about the graph? It can be drawn like this. This is center, this is capital R up to surface, this is small r, this is electric field intensity. Inside there is no electric field intensity, so no graph will be there, it will be 0. But outside it will be inversely proportional, E outside proportional 1 upon R square, and it will be maximum on the surface. Remember, it will be maximum on the surface. Then what about another graph? Another graph will be like this. It can be represented in this way. Here we can take electric field intensity. Then it is two-side graph, we can say. Capital R will be there, small r will be there. The graph will move in this way, in this way. This is electric field intensity. So this is all about determination of electric field intensity due to solid metal sphere in terms of graph as well as the values of formulas, that is E outside, on the surface, inside, center, and the variation in graph in two ways. You can represent graph in this way as well as in this way. Its results are very much similar to that of results of the determination of electric field intensity due to a hollow sphere, whether it was metal or non-metal. So I think this session become very useful for you. Please do subscribe, share and like our YouTube channel Physics by T C Chauhan Sir. Thank you very much.